All right. Hey, everybody. We are live. I'm here with Michael from Shadow Traffic, which is really fun, a really fun thing that we get to do. I'm going to just do a quick throw to what we're doing at MotherDuck and DuckDB, and then Michael gets to take us to show us how that works together with what he's up to at Shadow Traffic. So for those of you who don't know, MotherDuck and DuckDB are analytical databases. MotherDuck is taking all that goodness of a really fast embedded local database like DuckDB and make it run seamlessly in the cloud. As part of that, we've built an MCP server that we're going to show how it really nicely works into your dev workflows today when doing things like what Michael is up to over there at Shadow Traffic. So Michael, why don't you take us away?
Yeah, thanks, Jacob. Thanks so much for having me. It's been super fun to work with you on this stuff. So hey, everybody. My name is Michael. I'm the founder of Shadow Traffic. I'll share just a couple slides so you have something to look at while chat.
All right, they're up.
Awesome, fantastic. Yeah, I build a system called Shadow Traffic. Its purpose is to help you simulate production traffic to your backend. It's been super fun to build. I think the purpose is pretty intuitive. It helps engineers write better tests. It helps sales engineers run faster POCs. It helps marketers build more effective demos. It's been super fun to build with a variety of different customers. It's been fun to do a lot of integrations with targets, including MotherDuck, as we're demonstrate in a couple minutes. There's generally two reasons why you want to do synthetic traffic. One is to kind of have more realism of your data for more effective demos, just sort of bring more vertical specific data to whatever you're doing. But the other one that's a lot more interesting to, I think, many people is just to simulate traffic in a more effective pattern in terms of its volume, its velocity, its variety, those kinds of things. And that's kind of the essence of what Jacob and I are going to try to do today. MotherDuck's built a really cool MCP integration with their product, and Shadow Traffic is actually kind of a neat way to be able to bring it to life. And so, our thinking was that we're going to do a little bit of a back and forth here, where I'm going to run Shadow Traffic and to create a data set, a simple one that's easy to follow. And then I'm going to introduce kind of various iterations on it to make it more complicated, introduce kind of bugs and quirks and stuff. And Jacob's going to use the MCP server to be able to run SQL queries in the background to figure out, what's going on with the data set, to kind of hopefully show how it all works together.
We'll see how good I am at exploring the data. This is going to be fun.
Yeah, I will say I've used the MCP server a decent amount as you guys have been developing it, and it works really well. I think SQL is one of those use cases where like MCP is just perfect, where like you just of course know SQL if you want to actually write like very precise analytical queries, but there are lots of things where you just sort of want to do like a first degree of effort or a draft, and if you could just say it with English text, it's like the perfect use case for an LLM.
Yeah.
What is it that you want to do and get some kind of a result quickly out of the gate?
Yeah. I mean, totally agree. I mean, I think like it's one of those things where it's like you don't have space in your brain for like all of the syntax. It's like you are an expert in something else. Like, how can I let this other system handle that and like do it in a way that I can understand? And I think that's the power here, is that like you can bring your logical thinking and way you're looking at the data to natural language and not and have like get trusted results. And if you don't quite trust them, you can look at the thought traces too. So it's a great experience, I think, from that perspective.
Yeah, I think that's a great summary where most engineers are at. So shall we kick it off then?
Yeah, let's go. Let's do it.
All right, cool. So here's what's going to happen. I'm going to share my screen really quickly, and I'm going to set up two different things. I'm going to set up my terminal here on the left. I'm going to set up a text editor on the right, and I am going to generate some data to a shared database that Jacob and I have together. And the table it's going to generate data to is called game actions. I wanted to do a very simple data set just so everybody could fully understand what's going on.
Yeah.
If you complicate it too much, then it's just sort of tricky to follow. But I've got my terminal here. Shadow Traffic is a Docker-based piece of software. You run this wherever you want to run Docker. That could be your laptop. That could be Fargate or whatever. Mm-hmm. I'm just going to run it on my laptop and then point it to MotherDuck. And here is a Shadow Traffic file that we're going to start with, and I'll just run you through it really quickly. So
hang on one second, Michael. So I'm not seeing your screen. I can add it to the stage, but I'm seeing your Chrome browser as the shared view. I haven't pulled it up yet. Okay,
let's fix that. Let's say stop sharing.
Oh, okay. Yep.
Sorry for the technical difficulty.
That's okay. That's all right. We will get there. This part is always the fun part.
Always the hardest part. Okay.
Totally. Okay, I see your screen now. I think this is the right thing. Yep, this looks great.
Okay, there we go. Now, okay, we have terminal on the left, and now do we have text editor?
Yes, we do. It looks great.
Right, wonderful. Now I can see you. I can see my editor. I can see my terminal.
Yeah.
Great. Thanks. Okay. As I was saying, let's start shadow traffic and then put some data into MotherDuck. I'm going to run you through this file very quickly. I know it's a lot of syntax to grok, but this is just sort of a basic thing that we can put together. So we're going to generate data to a single table called game actions. We're going to simulate a very, very simple data set and introduce some variations on it. What we're going to do is generate rows of data that have 4 different columns. We're going to have a user ID, a username, an action, and a timestamp. The timestamp is going to be the current Unix millisecond time. The action is going to be one choice of move, attack, or swap, just some basic things. And then the user ID is going to be a UUID, and the username is going to be a full name. And the trick is we're going to create a cardinality on this data set where we're going to have up to 30 different user IDs, and we're going to create a correlation between the user ID and the username. And so this means we're going to see over the course of 30 different user IDs, the same username repeated every time, because that makes sense. If I have user ID 1, I should always see that means Jacob. And if I see user ID 2, that of course means Michael. Very obvious, but it creates that kind of correspondence that we'd want if you have sort of a more realistic data set. So I'm going to go ahead and run this, and hopefully everything works here. I'm going to say docker run, give it my license key that unlocks shadow traffic, and I'm going to say, here's my file called clicks. And then what I'm going to do, just so you can see the data before I actually get it rolling for real, I'm going to say send the data to standard out, and then give me 20 different samples. And this data is going to roll in at a clip of every one row every 50 milliseconds, so that we can have some amount of data sort of passing through. And you see all the data just flowing through on my terminal. It hasn't yet gone into MotherDuck, so it generally all looks good. I see, here's the table, user IDs are looking good. I see some names, I see some actions. That basically looks good. I am now going to basically just stream this data into MotherDuck indefinitely. So I'm going to say, watch this file, and then reload immediate. And as Jacob and I talk, I'm going to update this file over time. And whenever I edit this file, it's going to go ahead and basically change the stream as it updates. And so now it's loading up for real. It says, okay, let's connect to MotherDuck. It's going actually creating a table for me called game actions with my 4 different columns. And then hopefully everything is working really well, and all the data should be streaming in. And I actually think this is probably a good time to transition over to you, Jacob, if you want to take over the screen and see what MotherDuck can see in MCP to start asking some questions.
Yeah, absolutely. Okay. So let's see. I should be able to add this to the stage. Great. All right. So you should see my Claude Code terminal. I've added the MotherDuck MCP to it. It's now asking me to, run a tool. I'm not running with dangerously skip permissions. Okay. So it's not seeing it yet, which is totally fine. Let's see here. Let's see. Run the SQL query, refresh, database live stream. This is just how the replicas work. With the MCP, we actually have one more level of replicas, so you can get a little bit hairy. Okay. Yes, you can. Run it as a SQL query. Thank you.
I'm sure we're the first people in history to
like
what demo.
Like what is happening here? Like, it knows that you have a query tool. You have a query tool. You have a query tool. What? Why is it being like this? Use it. Use it. Like what are you doing? Like, come on. This is super funny. Yes. Okay. Now it knows it should do it. Refresh database. Oh, that makes sense actually. Okay. Well, let me run that on my side back here.
That's all right.
I have another window open. Let me kick that off. Okay, we should no. Okay, look at the tables. Oops, I did not want to full screen that. You stop that. Now my it's the wrong size.
Okay. Yeah, just increase the font a tiny bit and you're good.
Okay. Hang on, I will fix this. Skill issue for sure. Oh my god, please stop. There we go. Okay, do you want to ask? Yes. Okay, so I found the table. Found these. Good god. Okay.
Hey, there we go.
Look at that. Hey, we have 3,000 rows almost in there. So we can start asking questions about it. It's sampling the data. We can see timestamps. This is great. So anything interesting. What I love about this too is we can kind of be really vague with Claude about this data. And now that I've kind of accepted the tool usage in general, now it's kind of like just making queries. You can see, like, right, you're writing a bunch of queries here, right? What it's looking at.
What I think is interesting, I ran this before myself to make sure it would be a decent demo. And like that second query to me is actually pretty interesting in that it's capturing timestamp bounds, because when we ask it later queries, it knows to kind of segment off data that it's seen earlier. And I intentionally put timestamps in here so that it could basically do that kind of a sweeping query. And it's cool to see that happen out of the box.
Yeah, I mean, I think one thing that I've noticed, like, we've been using the MCP with a bunch of different models, and Claude, I'm using Claude Opus 4.5 right now, is that it definitely seems to be the most curious. And so I don't have to, I can kind of just be like, hey, this is weird. Can you look at it? And it will not just write one query, it will explore kind of its own intuition on that, which is very helpful. And so we can kind of like, we don't have to know what we're looking for before we're looking at it, which is one of the big challenges with data analysis, right? Is like, it's very iterative. And so this is a very natural way for you to start iterating on this. Okay, so it looks like it's in here. We see we've got some.
It's called me out for being fake, which
yeah, it has detected. You've been detected. This is likely a live stream demo. Yeah, well, we're live right now. We are actually live right now. Let's see.
I probably should have named the data set better to be more.
Yeah. So I was checking to see if there's new data now, right? Which is great. Hey, we have more rows. Awesome. So you can see actually it's really close to live right now. The last row is a few seconds ago. So this is great.
Very cool. Shall I introduce some challenges and or maybe not challenges, but some.
Oh man, you're making me nervous. Yes, let's do it.
All right, let me try to take the screen over again. So let
me I'll take mine off. I got to take mine off. Okay. And cool. Now we will wait for you to throw it back up there.
Screen allow, and then
if you leave it up, by the way, Michael, I can manage the stage part of it, and you can just keep it up, and we can just hide it. So that when we switch, we're good. Yeah.
Okay, cool. All right. So this was the file that I had. It is still over here running. What I'm going to do, just something really simple to see it kind of flex a little bit, is I'm going to go down to this this function. This is basically creates a cache and a correspondence between user IDs and names. But what I'm going to do is I'm going to add a function modifier, just something really simple here. I'm going to introduce the parameter null, and you can basically say, hey, some degree of the time, instead of generating a name, I actually just want to put null here. And then we could go and have MCP kind of investigate about what percentage of the time this is happening. Can it figure this out on its own that this is happening? So now I'm here, I'm saying, let's do 10% of all usernames are going to be null. As I save this file, you'll notice shadow traffic just dynamically restarted. It made sure that the table exists idempotently. And now that data is flowing in. If I actually went into the SQL editor on MotherDuck, I could go instantly poke around. It's actually very fast at ingesting data and being able to answer queries on it. Surprisingly fast for an analytical database, being able to do these kinds of introspective things.
Yeah, for sure. It's been a lot of fun. I think one thing that's really cool about this too is that, like, as you're seeing this, like, so as Michael's showing this part of it where like the data is changing, this also means as you think about how you use a tool like shadow traffic, is that like it's not just like a static generator, right? You could easily, whatever's running in Fargate or whatever, like inject changes into your config over time, right? So that as you're kind of looking at the data that's coming out of it, you can see the same experience that we are getting right now programmatically, right? And in fact, I bet you could even do this with like an AI also, right?
Yeah,
like
as long as you can kind of update the file system, you can re-trigger behavior, which is great for orchestrating these kinds of tests where you want to make changes over time dynamically. It's kind of, really powerful addition.
Yeah. Okay. So let's see. I don't want the challenge here is I know what you did, so now I have to like prompt it in a way that is not.
Yeah, I'll do more hidden changes.
Yeah, and just as a note, here's /MCP. We can see here's the MotherDuck MCP that's connected. It's very, very easy to connect. It's all in our docs. I'm just actually going to throw the quick start into our chat real quick here. There we go. So you can add it and start fooling around with it too. Okay.
Maybe you could ask it, is anything different or strange about this data set now? Something kind of like high level, like
Are you seeing anything interesting in the most? I'm just gonna. I'll kind of time box a little bit. In the latest data, like this is kind of unfair, I guess, but like we know too much. I know too much. Um, let's see. Okay, catches its own errors. What's really nice actually about this is because SQL is there's a linter kind of in the middle. If you write invalid SQL, it fixes itself, right? We actually had a bug that we detected. Oh,
Hey,
hey,
nice.
did find it. We found a bug that where we were not always generating the right SQL, and the MCP just kind of self-healed on it, which was very funny. You ended up using more tokens, but the MCP was like, "Oh, hey, this is wrong," and on like programmatic SQL we were generating and sending to it, and the AI models were able to just fix it and like almost like self-heal on it, which was very, very interesting. I've never seen that before in software.
Yeah,
It was kind of
it's nice to have those kind of layers of abstraction work well together rather than kind of
yeah.
be
I And
fuzzy
it was like
coding.
emergent, right? It wasn't like, oh, like we were like, hey, this seems like it's taking too many API calls. Like, why is this taking like 4 or 5 API calls? It should be 2. And it was like, oh, because it's getting a response back. This is bad SQL, and then the agent is fixing it like in the loop before it comes back to the UI. And it was like, oh, okay, like that's really nice. Okay, here we go. It found it, and it kind of gave us a nice description of what was happening here too.
Yeah, yeah,
Right?
perfect.
Nice demo of
Hold on.
handling null values in real time. Yeah.
All right, I've got another layer. Do we want to
Okay.
see this one? Or do we want this one to be hidden? I have 2 more.
Let's do. Why don't you hide it? I'll
Okay.
hide my screen for a minute since there's nothing happening. But
Okay. All right.
you can do something, and then we'll
All right, cool.
see
I'm
if
going
we
to
can.
change to something about data set, and then I'm going to fire away. And here we go.
Yeah.
All right, fantastic. I mentioned a lot. Actually, I don't want to. I don't want to say it.
Yeah.
I want to speak to it, but I don't want to speak to it yet.
We'll speak to it in a minute. I think
Yeah.
so like one thing that I found that like we haven't really explained here too is that this kind of workflow generalizes to more than just like, hey, like using shadow traffic to send data to mother duck is like if you think about what it looks like to maybe stream like logs, maybe like chain of thought traces or whatever, like into mother duck, and then just have like another tab open that's just like constantly checking the data, or maybe once a minute it's like making sure everything looks good, right? That's something that you can do as a human, right? But like it just adds an extra layer of validating that in your dev workflow where you can just make sure that you can do it in a very token efficient way, right? The other way to do that is like grep through your logs with AI, or you can just do that as a human. But like the fact that you get decent analysis kind of out of your Claude is I found very helpful when I'm working on like maybe complex agent workflows where I'm like, I have a bunch of JSON and debugging it is annoying.
Yeah,
This
I
has
think
been very helpful.
I was gonna say before you dive into it, like I actually think it's a good example of a general pattern that I've been adopting where if I have a problem, I'll often throw Claude at it and just say, like, what do you think? And then I'll close the tab for a few minutes and go think hard myself. And it's just like kind of having a spot check. And it's not always right, but like it's at least
Yeah.
either like another check or sometimes it guesses right when I guess wrong. And it's just nice to have a little bit of backup, even if it's not like always the cure.
Yeah, I think that's right. I think that's right. Like it's like a very I kind of think about it like a very good junior. Like it's very curious, but like it doesn't have all the context you have. And so often you're like, that would never be right. Like, how would you ever think that? It's like, oh, well, it doesn't know what I'm really trying to do here.
Yeah.
All right, let's see here. We have some new data coming in. Take a look at it.
Oh,
This
yeah,
will
go
this
ahead,
will be
go ahead.
interesting to see if it'll uh how much we can get in here.
Okay, so I got the first part right. It's a significant increase in the amount of data coming in.
Oh man, wow, that is way more.
This is
Okay.
cool. So
Um,
well, yeah, maybe poke around a little bit more. Maybe ask a little bit more about
well, don't
like
no. All right, don't
yeah,
say
yeah,
it.
yeah, yeah. Go ahead, go
No,
ahead.
like don't ruin the surprise.
All right.
Let's see. Can you look closer? Can you look closer? Think deeply. Think deeply. This is like always like the very fun like AI tricks. Like they're so silly, but they work. Anyways. All right. I mean, what I love about this too is like we're really we're kind of looking at the true problem here. We're not spending a bunch of time thinking about the SQL, right?
Yeah, totally.
Which can be helpful. I think like for the abstraction like this is very, very helpful, right? Okay, it did find some duplicates.
Yeah, kind of. I guess you. Yeah, it's a fair thing to pick up.
Let's see. This is doing a great. Okay, please. This is going too far.
Yeah, and it's made the assumption that like one action can only be done per 1 second per actor.
Oh, wait, let's see. Let's see. I think that's a bad assumption. I think it's a bad assumption that we can.
That's a bad assumption of our fake game that we're creating.
Yeah. That we can only do one action per second per actor. I mean, like I think, like obviously, if you're the one creating this data set, I think not you, but like the royal you, like when you're debugging your own logs, these are the type of context you need to add to it, right? Like to get good results.
Yeah.
Interesting. Exact same millisecond. Here's a question that I would have about this. Is the duplicate signal, is the timestamp on write, or is the timestamp being generated in shadow traffic?
Ooh, that's actually good. So yeah, the timestamp is in shadow traffic. So I guess from Claude's perspective, it actually is a duplicate because it's seeing the exact same millisecond value. Because, well, to reveal a little bit of it, so, obviously the data is coming in significantly faster now.
Yeah.
So I guess if it was on write timestamp, that would be even better to take it down to like the microsecond or the nanosecond level, right?
Well, I don't know. Like, I mean, like, because my assumption is like you're using like a bulk endpoint for writing into an analytical database, right? And so, like, I would expect that like your write timestamps would be less granular on the mother duck side than they will be in your data generator, right? So I'm just thinking about like, what does it look like to actually use this pattern, effectively? Anyways, let's see here. It looks like, so I think like it looks like there was a point in time where the data started coming in way faster.
It's like quite close of it. it's like hinting around the right area, but it hasn't really narrowed in on what's exactly going on yet.
Okay. So I'm trying to think about how else. I guess like the how else can I slice this? Well, I'll show you. I'll show. Okay.
Yeah.
Oh, it found it. Oh, there was there. We had a spike. Okay.
Yeah. Bingo.
Okay, so it did find it, but we had to kind of ask the right question. Okay. By the way, my trick on this sometimes with Claude is to be like, I'll do this. I'll be like, explore all the facets of this data, to confirm that hypothesis. And there's not this is a pretty simple data set, so there's not a lot of facets to explore. But if you think about like you identifying an outlier on maybe a larger data set with more joins, this is a very helpful way to be like, I've seen something weird, now let's confirm it's actually weird, right? And just like get a bunch of queries, make sure that like across all these different dimensions, everything kind of makes sense as being weird. Yeah,
it's quite helpful to be able to kind of do those cross checks. But yeah, like that table was perfect. Like basically I initiated a time-based spike where for some number of seconds we did an exponential ramp up in writes. We held at a peak, which it identified, and then we brought it back down. And like bingo, there it is. I'm actually curious to see what further it can add to kind of that claim.
Let's see. Strong evidence. Theaters and spike. Identical distributions. Love that. Okay. Okay. Duplicates happening at the exact same time. Sure. Whatever. We can call them duplicates, but it's not exactly right. Okay. So it's finding stuff. All right. I'm going to stop sharing and we can let it keep exploring while you set up another trap. Actually, I'll keep sharing.
Yeah, keep sharing. I'm going to do something off screen. I got one more to go.
Okay.
Drag a bunch of stuff already typed.
I'm going to actually cheat here. I don't want to pause it. All right, we're going to let it keep going.
All right, I'm generating new data while that populates for a minute or two. I actually thought one thing we were chatting about this before the live stream, but I thought it'd be interesting if others heard about how this is working in terms of shares. Database replication is like a notoriously hard problem where you have to balance liveliness and the ability to maintain rights and how to scale. And MotherDuck actually has a very reasonable approach where shares, these said they operate on about a minute lag, which is really good for an analytical database where you're generally prioritizing just having scale and you like always serve kind of real time reads off of these things. Is there anything you kind of might share about how that works?
Yeah, let me just resume my session. Okay. I just did something really fun that I'll talk about in a little bit to talk my own book, but we'll get there. Okay, this is a great question. So this kind of came up in the concept. I think everyone saw this OpenAI blog post about Postgres or over the weekend or last week. I can't remember. That was basically like, hey, we're using one big Postgres instance to run all of this. Run all of this. I think probably managing their user database. I'm not exactly sure for OpenAI. 800 million rows or 800 million users with all this with all this data in Postgres. And they had 50 replicas, which is a lot of replicas. So for those of you that know Postgres replication, replicas in Postgres are really heavy. In MotherDuck, because storage and compute are separated, they're actually really lightweight, which means you can get a lot of them. Like you can get hundreds of replicas if you want for scale out. Reading the same data, which is really, really cool. But the kind of trade-off there on separate storage and compute, right, means that like if you think about how it works behind the scenes to make sure there's no issues with snapshot consistency, basically how it works behind the scenes is that is MotherDuck takes a snapshot and then pushes it to all the replicas from primary to all the replicas. And so that happens on today about a 1 minute cadence. So you can, of course, there's commands to force a refresh on it, so you can actually make it go faster if you need to. And we do see occasionally some use cases for that. So it can be, for all intents and purposes, that moves it to like a more real time. But it does kind of go against some of the serverless nature of MotherDuck, right? Because now if you're fully streaming to a database and then running refreshes to all of your replicas, now you're paying for all of these databases to be up all the time, and it's a little bit of a different pattern, but it's all good. So one thing I want to do real quickly, now that I have this data, before I look more deeply, actually, how much time do we have? Oh, we're almost out of time. So we can keep rolling. We can keep rolling a little bit. Let's keep looking at the data, I guess.
Yeah,
okay,
let's do it. There should be enough data in there to
let's see. Okay,
going on.
So let's look at the data again. Anything interesting? Interesting since the last time we looked at it. Let's see. Not a replay. Synthetic bulk load. Yeah, I mean, sure.
Yeah, I was trying to get Claude to avoid recognizing that it's synthetic. It's actually very hard balancing like realism with making the demo so complicated where it's like, oh my gosh, I can't follow what's going on here.
Yeah. Like obviously, we've been using shadow traffic internally at MotherDuck to build lots of really fun demos and really kind of push what we're doing. And yes, building a data set that is not immediately clocked is fairly difficult. Maybe that's something I can write about in the future if I can ever get it to not get clocked immediately. Let's see here. Users joining in perfect batches of 30. Okay. Probably around when that happened. New cohort looks normal. What's funny is like it remembers these splits. It's kind of like checking those same assumptions without us having to explicitly tell it that information, right?
Yeah, that demarcating behavior is actually really useful when it's time series data, because otherwise you're kind of like manually trying to figure out, okay, F segments A, B, and C as it's changing over time.
Yeah. Okay. So new users, total users, 4 cohort. This is not, I don't think, what you did. So keep looking. Explore more facets.
Good instincts. I did something far more.
This is definitely not the hardest trick, right? Like, no, come on. This is way. Yeah. Again, like, what's funny is, for those of you that don't know, my background is actually accounting. I did accounting undergrad in college, in addition to computer science, and so this is all very familiar to me. Like, keep looking. There's more here. You got to keep looking. I love that I can have an AI do it now instead of me. Okay. Millisecond distribution not uniform. Let's see if this is interesting. This pattern suggests, yeah, okay, please stop that. It's like too aware. It's like too aware.
Yeah.
Let's see. Name. Okay, great. I'm glad that you're aware of Faker. Like, stop that. I wonder how much it's like trained on that. Like, I assume that like in the synthetic data generation that's going into these LLMs, like Faker, they must be using Faker.
Yeah, I actually thought about replacing Shadow Traffic's like bulk string library. I've always used Faker with like something from like census data to just try to avoid these things a little bit more. It probably doesn't matter that much on the margins, but it can be helpful for use cases like this.
I will say I'll just +1 that idea because I have basically replaced the generator that we've been using for internal generation with just like a JSON file with like thousands of names that it just pulls from.
Yeah, yeah, totally.
Which I think is probably not uncommon, but like,
it's like it's very fixated on things that have been true of the data set the whole time. Can I hint it? Can I hint you?
Yeah, give me a hint. Give me a hint.
It has something to do with the timestamps that are coming in that is different than what they've been in the past as far as pattern.
Okay. Well, it might have just like discovered. Was it listening to me? This is interesting. This is something. This is something that is somewhat indicative of what you just talked about.
Yeah.
Okay. Stop duplicate. There's not duplicates. There's no dupes. I think I think.
Well. Okay. So I wish it didn't think about the duplicates thing before, because
now there's dupes.
Yeah. Now it is onto the right thing. I wish I had caught the millisecond timestamp thing, because like now there are true duplicate rows in addition to something else going on.
Okay, let's see here. Okay, let's see. I have it confirmed. Let's see. I've confirmed there's true duplicate rows. True duplicate rows. Let's see. Yeah, we know that. Like, stop that. Oh my gosh, this is so funny. Yeah. Okay.
Yeah, spot on. So it's got one facet of this. It said exact duplicate rows, same user ID, same name. There's a knob in Shadow Traffic where you could say, I'd like to repeat rows at some number of times at some probability. I basically cranked it up and said,
yeah.
3% of the time I want to have a duplicate of these things. And so yeah, there you go. You see basically that
oh, here's the distribution. Yeah, I see that. Okay, let me let's see here. How do we want to? All right. Can you hint me at the next part? Is it something?
Yeah. So as I was saying, it has to do with the pattern of the timestamps. That column is the thing that's different than what was going on before.
Take a look at the change in the pattern of the timestamps. There's something going on there. Since, let's just do 1155. By the way, can you go a little bit longer here, Michael? We are.
Oh, yeah.
Great. We'll go a few more.
I always block a little bit at the end of.
Okay, great. We'll keep rolling here then. Okay. So we'll just see if it identifies it. Okay, there's a gap and a drop. That's probably like when the config changed, honestly.
It's close now. Now it's really close, I think.
That didn't. Okay.
Keep searching, buddy. You're getting close.
Keep looking. Let's see here.
It's kind of in the weeds talking about collisions.
Yeah, I see that. It's like it's so it's like a little fixated. It's not collisions. I think one thing I think is you can do like by the way like this. It's not collisions, and it'll inject it right in to the next. Time I think that's how it works. There's some sort of way to do this in Claude where it'll just inject that into like what it's currently thinking about.
Oh, it's nice.
I don't think that's the right. I don't think I did it the right way. Do you do it like a slash? No. Okay. Yeah. There's some sort of way to do
// BTW.
Yeah. I can't remember. But anyways, yeah. Okay, so this is great though, because we can have it keep looking at it while things are continuing to occur, which is a great, I think, like a nice async, keeps us focused on the problem we're working on, which is something a little bit more difficult than this. And then go from there. Okay, here we go. What? Here we go. Maybe.
Whoa, where's it gonna go with this? It's like maybe.
Yeah. Like, is this it? Is there some pattern there? Let's just see.
I was just gonna say, like, broadly, despite the data set being obviously canned with some irregularities, but like this is a pretty good example where you have some bug, you're not sure what's going on, and you kind of have this helper sitting in the background. It doesn't need to be perfect. It just needs to generate enough hypotheses with some level of direction that can kind of like take away a little bit of the burden from you. And it's
that's right. That's right. I mean, it also like seeds ideas in your head too, right? So it's like, oh, like I didn't think about that facet. Let me go look at that. Totally.
Yeah.
Okay. Let's do.
It's so close. Do you want me to give it to you?
Yeah, sure. Tell me what happened. What do we do?
It's like, because it's thinking so hard about the millisecond collision boundary. It's like there but almost there. What I did was I took I obviously. Actually, I'll share screen if I can to make this even.
Yeah, sure. Here, I'll throw you on. I'm going to remove myself. I'm going to throw you on stage. I just see your background right now. There we go. Yep.
Perfect. Okay, so what I did was I took my shadow traffic file and I removed the spike thing that I had, where instead of doing it every 15 milliseconds, creating a row, I put it back to, let's do a row every 15 milliseconds, and I introduced these two knobs. The one that you did find was I repeated 3% of the rows an extra time, and then I also swapped the order of 5% of the rows every 100 milliseconds. And so what I was hoping it would find, we'd look at some of the rows and realize for the entire corpus of the data until just before then, all of the timestamps should be 100% serial in a row. But after that, you should actually see rows where they're coming in out of order some percentage of the time, suggesting some kind of lag or delay or like.
Okay, so it like kind of found it, but like not quite. It was like it was really close.
Yeah, that's why I was like, we're very close, but I don't know how to say it without giving it away.
yeah. Like it's all yeah. I mean, also like when you're the developer and you have little finer grained controls, or you're kind of making the changes on the system, it's very helpful. I will say, like, where it gets really hard is when you have a really complex system and you're not quite sure how things are working. This is also a great thing, just like keep running at the same time as you're like querying it, right? Like, what the heck is happening? I haven't had the pleasure of using it when like there's an incident happening, but I could imagine that like having Claude in one window and yourself in Datadog or whatever, is like a very powerful pattern.
Yeah. Totally.
All right. So I'm going to show one more thing here. Let's see if I can get it to work. Which is, we did a bunch of research. So like, let's throw this into a markdown file that we can visualize in a chart. I'm just going to give it permissions to do stuff. Great. Generate these things. NPX. So it's a skill called MViz, which I added. And I've been working on this kind of behind the scenes. You can check it out if you want. It's under my personal GitHub repo, matsonj/mviz. And it's going to open it. And okay, let me share a different window. Where did my screen go? I'm going to stop sharing. Let's stop sharing and let's reshare. So now we have a data quality report.
This is one of my favorite use cases for Claude, where you like change the modality of what you're doing away from code to something visual or to documentation.
Totally.
Be perfect, but like pretty good is actually often sufficient for this stuff.
Yeah, it's like, okay, I can explain this. If I want to make some changes, I can. Here it kind of does it. It's funny, it doesn't like use any time series charts, which it should, but like we're getting close. Like my guess is this almost does it. Like, give this to me as a line chart. Like, come on.
That's pretty much it. Like what I had injected in is basically that curve in terms of a bar chart.
Yeah. So I wish it was a line chart, but that's a separate problem. Anyways, so that's kind of like how I'm thinking about all of this workflow is like, okay, like we've done all this work, we've understood what's happening. I want to be able to create some artifact that I can share with other people, and that's how I'm thinking about this skill and tying all these pieces together. Michael, anything you want to share? Any links you want to share? I'm happy to drop them in.
Shadow Traffic IO, check it out. It's been a fun thing to be able to use in conjunction with MotherDoc. I've really enjoyed not just trying the MCP server, but MotherDuck's UI is fantastic as a SQL editor. I've consistently told the team this since I started working with them. It's the best SQL editor experience I've had since I started programming over like 13, 14 years ago.
Yeah.
It just works well. It has good visualizations as you work. The AI integration is really good for just auto correcting like the dumb mistakes you make where you like mess up the syntax. Really check it out. It's very clean. I think you'd be satisfied.
Yeah, we've been we work really hard on that, and I think part of it is like I love this MCP notion that we've added because it puts us in the place of like now you don't have to think about SQL, which is I think what most software developers prefer. And so like let's make that easy.
But when you do, the UI is like perfect to fall back.
Yeah. When you do need it, it's there. The AI is great to like, especially because the syntax can be pretty gnarly. It's very verbose. Being able to ask natural language, like, hey, like help me write a query on X, which is integrated into the UI, is really, really helpful. So yeah, thank you so much, Michael. Thanks for going over time with us. This is really great. I think we showed some really, really cool patterns. Love what you're doing at Shadow Traffic, and we'll sign off here. Thanks, everybody.
See ya.
All righty.